Here we're going to be composing more functions together. This time we have a square root function with a linear function. F of x is the square root of x plus 4, and g of x is 5 minus 4x. And we're going to first plug in some numbers. If you plug in a number, you get out a number. If you combine a function, you're going to get out a function. So starting with some numbers, we have f of g of 1, which first requires me to calculate what g of 1 is. So off to the side here, g of 1 is going to be 5 minus 4 times 1. I'm going to replace the x with a 1, and that's going to give me 5 minus 4, which is 1. So I'm really doing f of 1. And now I'm going to plug into the function f. For f of 1, I'm going to have the square root of 1 plus 4, which is the square root of 5. So f of g of 1 is the square root of 5. We're going to see if that is the same as doing it the other way, which is g of f of 1. We always work our way from the inside out. So I'm going to start by plugging in f of 1. I'm going up to here. If I plug in f of 1, I'd get the square root of 1 plus 4. Which gives me the square root of 5. So really here I'm doing g of the square root of 5, which means I'm going to go into the function for g of x and replace that x with root 5. G of the square root of 5 is going to be 5 minus 4 root 5, which is going to come out to be a crazy decimal, so I'm going to leave it as 5 minus 4 root 5. So you plug into the inner function first, and then take that result and plug it into the outer function. Now I'm going to find some formulas. I'm going to find f of g of x. If I'm plugging in an x, then I'm going to get out an equation. If I'm plugging in a number, I'll get out a number. So we're starting with f of g of x, which means I'm going to go into the function f and replace each x with whatever g of x is. G of x is 5 minus 4x. So I'm going to go into the function f, which is the square root of x plus 4, and I'm going to replace x with 5 minus 4x. Instead of x plus 4, it's 5 minus 4x plus 4, which tells me that f of g of x, when I combine some like terms, under that square root, I have 5 plus 4 is 9 minus 4x. So we have the square root of 9 minus 4x when we do f of g of x. How does that compare if we do the composition the other way? Finding g of f of x means into g I'm plugging in the entire function f of x, which is the square root of x plus 4. So within g, which is 5 minus 4x, I'm replacing the x with the square root of x plus 4. So really, for g of f of x, I get 5 minus 4 square roots of x plus 4. So do we get the exact same function if we do f of g of x compared to if we do g of f of x? No. We'll see why that is in just a little bit, but sometimes when you compose them, you get the same function, and other times you don't, and there is a specific reason as to why. So for this one, we do not get the exact same function. Order does matter. G of f of 1 and f of g of 1 were not equal, and neither were f of g of x and g of f of x.